All right, so this demonstration is going to be this 2016 free response question number 2, and there are 3 parts to it. So it says this question involves 2 classes that are used to process log messages. A list of sample log messages is given below. So here's the log message. It says log messages have the format machine ID : description. Machine ID identifies the computer and description describes the event being logged. Exactly 1 colon appears in a log message. There are no blanks either immediately before or immediately after the colon. So you got your name of your machine, colon, and then the message. Security alert dash repeated login failures. Okay, cool. Okay, so the following log message class is used to represent a log message. So you got log message, you got private instance variables that are strings, machine ID, and description, kind of what we went above here. This is part A, which is the constructor log message. A message gets passed in. So like that would be the message passed in. And the precondition is that it's a valid log message. Okay. So that's part A. So let's go down here. It says, write the constructor for log message class. It must initialize private data of the object so that get machine ID returns the machine ID part of the message and get description returns the description part. So you're initializing the private data, and the private data is the machine ID and the string description. Okay. All right. So when this message comes in, that would be assigned to the machine ID, and that would be assigned to the description. And so how would you know how to split those up? Well, don't all of them have a colon in there? And so from 0 to the basically 1 before the colon, that's your machine ID. And then 1 after the colon to the end is your description. So that's pretty easy to write. So I have that right here. So my colon, where my colon is at, is going to be equal to the message dot index of, and then we'll search for the colon. So if it finds that, then it will return the position that it's in. So 0, 1, 2, 3, 4, 5, 6, 7. 7 would be returned right there. So 0 to the colon index position of 7 is where our machine ID would be, and then colon plus 1, yeah, would be, yeah. So what do we have here? We got machine ID. So machine ID is going to be equal to the message dot substring 0 to colon. And it's not 0 to colon. So, and that would be 7, remember, but it's really 7 minus 1, right, with the way substring works. So you minus 1 from that. And that would be, that's easy. And this one's easy too. The description would be equal to the message dot substring. And remember I said it would be where your colon position is, plus 1. And then, because if you only do 1 parameter in substring, then it just goes to wherever that is to the very end. So that initializes your variable, and part A is done. That's pretty easy. Let's see here. It's part B. It contains a word. So it returns true if the description in the log message properly contains the keyword, false otherwise. So let's go down because there's going to be more to it than this. So it says write the log message method contains word which contains. All right, sorry, I got interrupted by that bell, so I wanted to pause the video. Let me read this again. Write the log message method contains word returns true if the description in the log message properly contains a given word and returns false otherwise. A description properly contains a keyword if all of the following conditions are true. The keyword is a substring of the description. So that would be like that, right? So if let me look real quick on this. So the keyword gets passed in, and if the keyword passed in disk is the same thing as the description disk is equal to disk, so that works. The keyword is either at the beginning of the description or it is immediately preceded by a space. So that would be like, well, there's not an example here. I'm surprised they didn't do that. So that would be almost like, oops. Let's do, you open up a Word document here. So I can come back to this and I can write some examples down. So that would be like, it'd be like this one. It would be like, let me make this a little bit larger. So that would be like disk space on DSK1. I just chose DSK1 because I saw that in there, but the keyword is either at the beginning of the description or it is immediately preceded by a space. So that would be, this one's at the beginning and there's a space afterwards, okay? So that would be okay. The keyword is at the end of the description or it is immediately followed. So I want to do this one right here. So that one works. So let me throw that in my Word document. I already lose the word. There it is. So this one is okay. Let's see here. Disk, that's okay. I'm surprised they didn't do more examples of, really what they're looking for. So this one is okay. So this one is just equal to, right? This one would be like the keyword plus a space, a blank space, right? And this would be like the keyword, this would be like before and after, so it'd be a space plus the keyword. So let me make all these Courier News because I like that format. Maybe like 16 is good. Layout margins, half. All right, and then what was the next one? The keyword is either at the end of the description or it is immediately followed at the end or followed by a space. So look at this one. This one's at the end. This isn't at the end because there's a 3 afterwards, so that won't work. So you can't just do a space before it because this one might not work. And so maybe I'll copy this one down because this is a good example where you couldn't just, that's not okay. You couldn't just check to see if it's keyword plus, a blank plus the keyword. So you got to do something else there. So let's do. So this one's okay. So let's do a. When we write this, we're gonna have to do a bunch of if-else statements for this, okay? Or just a bunch of if statements, really. So if my description dot equals the keyword then I can return true. What was the other one? So that one's easy. Keyword plus a blank space. This one's an easy one too. But we need to have the index of here. It has to return. So it'd be like if the description dot index of, and it has to find the keyword plus a blank space. If it does, and so it has to be able to actually find it. So if that's equal to position 0, so that's at the very beginning, and then there's a space afterwards. If that's found at position 0, then return true. Now, same kind of thing goes. If it finds it somewhere in here, there's a space before and after. Okay, so that would almost be exactly like this. So that is okay. Now, the last one is by far the hardest one. So, let's see here. So this one's not okay, but if we did something like this where we said, error on disk, that would be okay. But we can't just say that and check to see if that exists, because this example would screw up just doing something simple like that, all right? So we have to come up with an algorithm to see how to do this, all right? So this is what, let's see here. So this is the last, well, by the way, we want to return false if none of this stuff works. So you want to make sure you do that. So if So we want to first check if the description dot length is greater than the keyword dot length. Okay, because you could have stuff blow up on you. And you would say, let's think about this. Yeah. All right, so we wanna let's look at this. Sorry, I paused the movie and I was thinking through a good way to, instead of just sitting here thinking, a good way to talk through how to solve this one, okay? Because you can't, like I said, with this example, you can't just do this, all right? So if I put my indexes above here, I know that my length, I know that my description dot length is 13, right? So I want to be able to get to this part to see if there's a space before disk, okay? And so the way that, and just the way that I would do that, I need to get to position 8. So I need to substring 8 to the end, okay? And so I need to go description dot length, and I know that my message that my keyword is disk, and I know that the keyword dot length is 4. So if I did keyword dot length, that would give me 13 minus 4 is 9, right? That gives me right there. So that'd be 9, but then I need to do an 8 to see if there's a blank space before it. So then I would do another minus 1. So that gives me 13 minus 4 minus 1, and that would give me, so that would give me 8. So that's position 8. So that I can get that substring. So let's try that now. So right here I would say if my, let me think through this, my description dot substring, because I'm peeling that off, my description dot length minus my keyword dot length minus 1. Does dot equals, does that equal a blank plus my keyword? And if it does, you see here, so that is that. Okay, so this closes this. This needs to close. Here. 1, 2, 3. I feel like I'm missing. So opening, closing, opening, closing. Opening, closing. Okay, so I think that's right. So this one, this right here, again, is the substring, and I want to be able to kind of go backwards, really, because I'm checking to see, I'm going backwards to see if, you know, there's a blank before this. But then by doing this, it also tests to make sure that they didn't put something right after, and so that solves that. Again, that's a pretty hard algorithm to come up with off the fly without any testing. So, you know, again, the first, you know, this is easy, this is easy, this is easy, and that's easy. Just to actually come up with this and think through, you know, and hopefully you're keying off of this one's an error and why it's an error. There's something afterwards. But, you know, if you're not able to get this one right here, I'm sure this is a small half point right here. I'm sure the bulk of the points are within, you know, this right there. We'll go through the answer sheet here in a minute, but my guess is that this isn't going to be the biggest point on here, but we'll see. Okay, so that's B. And then C, let's see, C's on a whole new page. So A, there's B, and then C. It says the system log class represents a list of log messages. So there's our list of log messages called message list. It provides a method that removes and returns a list of all the log messages, if any, that properly contain a given keyword. The messages in the return list appear in the same order in which they originally appeared in the system log. If no message properly contains a keyword, an empty list is returned. The declaration of the system log class is shown below. So it removes from the system log all entries whose descriptions properly contain the keyword and returns a list, possibly empty, containing the removed entries. Entries in the return list properly contain keyword and are in the order in which they appeared in the system log. The remaining entries in the system log do not properly contain keyword and are in the original order. The return list is empty if so here's the original, and it's best just to use their example. So if disk was the call log, the log.remove message disk would return a list containing the log message objects represented the following log message. After the call, it would contain the following. So if you have that, you have this disk, which one would it remove? It would not remove that, but it would remove that. Okay, so that would be the first one that was removed. Disk isn't in here. Disk is in the middle there, so it would remove that. Disk is in here, so it would remove that. So these are ones removed. And then disk is at the end, but there's no space before it, so it would not remove that. So there would be like a removal log that would have those removed, and this would be what, and that would be what would be returned. And these ones wouldn't be affected. Alright, so first of all, we want to create some sort of removed log message array with all the ones that are being removed. Okay. So in order to do that, let's see here. So this is the message list, and so this is going to be the message list is going to be the one where we're going to remove them, but then we need to add to a different removed log. So I don't know, let's see here. I'm going to just copy that. I don't know, we can call it just the removed. I'm going to call it removed log. And that's going to be equal to a new array list of log message. Okay. And so then we've got to run through all the message lists. So since we're removing things, I think the answer that they give is different than what I like to use. So I like to use this while loop. And then we're going to, what at the end? We're going to return the removed log. So to be honest, right here, you'd get points for doing something like this, even though you're going to want to do a while loop. I don't know. I wouldn't do a for loop on these when you're doing removes because, well, I'll show you the answer in a minute. I don't like the way they do it. So I'm going to say int I equals 0. And so I'll say while I is less than the message list dot size. And there was an example on this in one of the other array lists. So if you remove it, you remember, like, I think it was the cookie order. So let me see if I've got that still. Remember what I said with the for loop? So you're kind of comparing what's being passed in. And here's your cookie order list, and you want to remove all instances of like chocolate chip. Let's do this. So if you use dot remove for what's at position 0, then the chocolate chip right here gets moved into position 0. But with the way that the for loop works, you add 1 to I, and so if you had this originally and you remove this one, then your new list is this right here. Okay, so now chocolate chip right here, which was at 1, gets pushed to position 0, and oatmeal goes into position 1. But the problem is when you use a for loop, I gets added up after each iteration. So then chocolate chip is now back to 0, but my I is now looking at everything in position 1. And does chocolate chip exist in position 1? No, but we didn't remove all instances of it. That's what we're doing here as well with this one. So I don't want to add up I if I remove something. I want to stay in the same position of I where I'm at and then just keep running through this. So if my message list dot get what's in position I. And again, let's see the different, the examples. I'm good. This is position 0, 1. This is 1, 2, 3, 4, and then 5. So I get to here. I would remove that, and then everything would get pushed up. And now I want to stay at position 0 to check through. Sorry, this one would be skipped because disk isn't in it. But then I would remove that one, and then this gets pushed up, and I want to be able to check this one. I don't want to skip over it, if that makes sense. And maybe this is best. Well, I couldn't write all that out on one line. I mean, maybe I could. Let's see down here. I'd have to go to the end here. But I think it's probably best if we wrote this out kind of like this. Format, I got to get rid of word wrap so that this, this is position 0. This is really kind of hard to read. I'm just going to put these in the middle the best I can. Position 1 of my 2, 3, 4, and 5. I don't think there's anything else over there. Yeah. So again, with this one, we wouldn't remove that because disk isn't in there, but this one we would remove it, and so then this one would get pushed down into position 1. And we would still want to test it. But if we do a loop with that, we can finagle the loop, but again, I don't like it. I only want to add this up if we don't remove something, okay? So dot, and then don't we check? So we've got to now implement our contains, right? Because this is going to check to see if it's in there. So we want to implement this. So at I, does it contain the word, the keyword? Okay. So this is where dot get I dot contains word keyword. So if it contains the keyword, then we want to this is going to be the removed log, so we want to actually build that here. So we'll say removed log dot add. Now this is really slick as well because we can say message list dot remove. What's that position I? So this would remove what's at I, and then it also can add at the same time. So that's super slick right there. Because remove, it removes it, but it returns what's removed. So it would skip this one. It would remove that and return it right there, and then it would add this to the removed log. So this one is also pretty difficult in my mind to be able, like, I feel like we could do this, writing this out with a computer in front of us pretty easy, but being able to do this on the fly with, 15 minutes, no, I mean 18 minutes or whatever it is, 20, 40, yeah, about 20 minutes. That's pretty hard in my mind to think through. Let's see where the points are. because that's kind of important to strategizing how to do this. And see, look at this. The C I just went through. Again, I don't like how we do this. So you add it, you go through all of them, and then you have to remember to subtract out an I. So if you start at 0, you can remove it, and then this would be -1, and then it would go back up, and then it would be, you would add 1 to make it 0 again. I don't know. To me, if you're going to remove something, I like this while loop a bit better. It makes more sense in my mind, but, you know, to all their own. If you guys like doing C like this better, then do it by all means. Let me see if there's a log message. Okay, so they give a point if you locate the colon for part A, which, you know, index of finds the colon. That's an easy point. Initialize instance variables with the correct parts of the parameter. So that's, you get another point if you do that properly and you initialize both variables. I'm kind of surprised here. I don't like the idea that that's a whole point. I would have rather seen a half a point where it would say machine ID, you know, initialize machine ID properly, half a point. Initialize description properly, another half point. But I guess you have to do both of them properly to get the full point. Okay. And again, you don't ever have a sheet like this on your AP test to tell you what you need to do. And that would actually be nice if they could give you something like this, you know, and say go at it. You know, then you need it. Then you know what you need to do. But again, they never create these until they start grading them, and they don't start grading them until a couple weeks or a few weeks after you're done with the test, because the grading doesn't even start till the first or second week of the summer. So the teachers, you know, the AP people don't even know what the rubric is going to look like. So part B, it's worth 2 points. So identify at least one properly contained occurrence of the keyword. Returns true if and only if description properly contains keyword. Returns false otherwise. Returns true if and only if description properly contains keyword. So again, you know, it is what it is. I thought they would give you more points, but if you just do that right there, you would get a point because you check to see at least one properly contained occurrence of keyword in the description. Okay, you would then have to do all the rest of these to get your next point. Okay, and again, this one is really hard to do. So, you know, that point right there would be difficult to get. Okay. Part C, it's worth 5 points. So, again, I don't know. Part C may not be as hard as I kind of made it out to be. Maybe it's not that hard. Maybe it's okay. Remove a log message containing the keyword from the system and return the message in a new list. Okay, so access all elements in the message. No bounds, errors, point loss if no removal attempted. So, you know, that accesses all of them and that removes them. So that would be an attempt. Let's see here. Identifies the keyword containing entry using contains. So that would give you another point. Add all and only identified entries to the new list. So that's right here. That's a point. Removes all identified entries. That one is the point right there. and constructs and returns the new log message. So that's, it constructs it right here and then it returns it. So, you know, what would be interesting to see here too for part C, these are different kid answers. So look at this one. This is what I'm saying here. Oh, no, they do it backwards. So this is actually, that would actually be fine, I would believe. I don't know. We can maybe go through this sometime, but I went through, you know, the way that I did it, so it works. So anyway, this video is done.